All right, welcome. Thanks for coming to this session on the last day of TC. Ryan and I are really excited to present this talk on semantics and how we're thinking about semantics in visual analysis and at Tableau. So a little background about me. My name is Vidya Settler. I've been at Tableau for almost 6 years now. Have a background in natural language processing, graphics, and information visualization. And I graduated from Northwestern University, so any Wildcats in the audience? No? Okay, we had a few in our last session, but yeah. And I'm part of the Ask Data team.
Awesome, thanks. I also am a manager on the Ask Data team. Before working at Tableau, I was the CTO and co-founder of a startup called ClearGraph, which Tableau acquired in August of last year. And before that, I studied computer science at Stanford. So I'll turn it over to Vidya to kick us off.
Cool. So we'll just do a little warm-up exercise to get started. Is there anybody brave enough to stand up and say the color and not the words that you see on the screen? Anybody wants to go? Okay, there you go.
Red, blue, green, yellow, green, black, blue, red. Yellow, black, yellow, blue, green, red, black.
Great. So you did pretty well, better than the average person, but you know, with TC we have a lot of smart people here, so I should know better. But in general, this is a challenging exercise for people because the speed of processing slows down when our brain tends to read words faster than actually looking at the color. And with this particular exercise, it's even more exasperated because the word and the colors are not semantically tied together. So it looks like you probably pause even for a few microseconds before saying the right answer, but that's great. So this particular effect in psychology is called the Stroop effect. And I will come back to this when I'm walking through some examples, and I might have a pop quiz along the way. All right, so let's talk about meaning. So we as humans we're constantly seeking meaning in our lives, whether it's during a fun dinner with your colleagues at the French Quarter, whether it's attending sessions at TC and learning more about how to use Tableau, going through your email, looking at the TC app. In general, we're trying to make sense of the things around us and about the stuff that we care about. But meaning is rather an abstract concept. It's really hard to codify that into something that's concrete or tangible. And semantics is a way to take that meaning and express that in some tangible way. And what does that mean in terms of using semantics with respect to data? I will walk you through a bunch of examples. Some of these actually, a lot of these stemmed out from research originally, and some of them have made it into product. And I'll highlight as I go which of these projects and ideas are actually in product. So one particular example for thinking about semantics and data is visual encodings such as icons. A lot of people, if you've gone through Tableau Public or even in your own workflows, might have included icons in your data visualization either to enhance the meaning or to add more pop or make the visualization more interesting. But these graphics are traditionally abstract. So this is an example of a log scale showing the relationship between brain and body mass for various animals. So if you were to look and study this graph for a moment, your eye has to wander to the blue points and try to associate the labels with those points before deciphering a pattern. But what if we apply semantics to express the meaning of this graph? where we use icons that are semantically connected to these animals, and this graph immediately becomes more meaningful and hence more useful because you could see these patterns a lot more clearer. So how did we actually go about developing an algorithm that can automatically generate semantically meaningful icons with categorical data, whether it's animals or sports teams and so forth? So the initial icon algorithm was pretty naive. What we did was take a bunch of categorical data, sports teams or countries or company stock ticker names, and try to come up with meaningful imagery from the web. Can anyone tell me what is wrong with this, this slide? Is there anything wrong, anything odd that comes to mind? Yes?
There's not a uniformity of presentation within categories.
Perfect. What's your name again? Susan. Thanks, Susan. Yes, that is exactly right. So as Susan said, there is basically inconsistency in the visual representation of these images, even though they are semantically meaningful. So for example, the backgrounds are different. In the first row, there's a black background on one of the images. A couple of them have a white background. Canada in the second row is brighter than the flag for India. And the problem with these inconsistencies is it adds noise to the data and can be distracting. So my visual system might look at a graph with these flag images, and I might think that there's something important going on in Canada, and India is not very important here. So in addition to semantic association, it's really important to have visual consistency as we're representing the data. So we iterated on this algorithm and applied image clustering based on some heuristics to try to identify for each of the categorical data what is a set of canonical images from each group that has similar visual consistency. So some of the things we were looking at is, similar aspect ratio, color distribution, background, and so forth. And by doing this clustering and reapplying it in the algorithm to these images, we got, this final set of results, which I would say is much better than the first set. So this is an example of research where data semantics and computer graphics both come into play to automate visual encodings that make sense for data representation. So as we're talking about icon assignment, another similar visual encoding is around color. And as we know in Tableau, there's a bunch of standard color palettes that can be associated with data, but they're not necessarily mapped semantically to data. So what did we do about this? Are people familiar with XKCD at all? Okay, if you haven't encountered this comic blog, I highly recommend it. So Randall Munroe is an American cartoonist who has this online comic blog called XKCD. And several years ago, he put out this survey where he showed people a bunch of color swatches and asked people to name them. And as you can see here, the men stuck to the basics, right? But the nice thing about this data was it was a huge corpus crowdsourced from people that had responses mapping color names to color swatches. So that rich data set was really useful for a bunch of research that came out of Tableau and from other universities where they use this to try to come up with semantically resonant color palettes. So we had this XKCD data, and in addition to this, Google decided to digitize books, millions of books, all the way until 2008. And then they have this feature called the Ngram Viewer, and you can actually go and visit this app. It's online, where you can peruse through all these digitized books and search for phrases, search for common words that occur with others. It's kind of a very fascinating data set to use. So what we did was we took these categorical items, whether it was a list of vegetables or sports teams or countries, and tried to find out how often is a word associated with a color. So for example, if I say the word taxi, what colors come to mind? Yellow, right? So, even though words may not depict color per se, there tends to be some association to these values. Not always, but for a large extent. So we use that. So in this case, canary tends to be strongly associated with yellow, green a little bit, but not with any other colors such as blue, gray, black, and so forth. So using this data along with the color survey data, we could take something like this, where you might have data consisting of a list of vegetables, you put it into Tableau, and you get this standard Tableau 10 color palette, where broccoli is assigned to blue. And if you remember the exercise that I showed you at the beginning of the talk, the Stroop effect, this can get confusing because your visual system is trying to map the color to the data in addition to processing the patterns in the data. So we were able to apply the algorithm that we developed and to the same data set, and now you could see that broccoli has a happy green associated with it, right? So, just simple things to improve defaults if the system has some inkling in terms of what the underlying meaning of the data is. So in addition to using semantics and applying semantics to more meaningful visual encodings, I'm going to walk you through a few examples where semantics can help make more informed defaults with respect to data. So let's start with location. I'll have a table here with a bunch of cities and sales. And if I want to represent this on a map, where do you think the data would be? Texas. You think for all points? Yeah. Okay. So when we first put this in Tableau many years ago, before any sort of smarts were built in, Tableau would do this. It didn't have any sort of geocoding information. It would take Paris and apply place prominence and try to say, okay, I think Paris means Paris, France, and then I will plot all the other points in Texas. And that's not what the user expected. Instead, a user expected probably something like this, where there is indeed a place called Paris in Texas. I don't know if anybody is from Texas in the audience. Did you know about that? Okay, cool. So this is definitely better, and this is what is more expected. And what we did build here at Tableau was looking at the context of the data and the characteristics of the data to try to infer if there is ambiguity, like in Paris, whether it's Paris, France, or Texas, to look at the dominant pattern that exists in the data to make a smart choice. And that algorithm got fed into the map search or geographic search feature, which is currently in Tableau. So if you were to render a map in Tableau and you were to search for a place using the map search feature, the algorithm is data aware. So searching for Paris would bubble up Paris, Texas to the top of the list, and Paris, France, is indicated here, is ranked to the bottom. So just like location and the context of the points can help with better data awareness related ranking algorithms, the same principle is also applied to dates in Tableau. So I might have a data set with a bunch of stringy dates that are not really marked as dates. And as we know, there are so many different variants in in the way people can express dates. You know, does day come first? Does month come first? Does year come first? And so forth. So it's really hard to understand what might be the default date format. But in this case, in the first image, 4:15:08 gives it away because you can't have a month greater than 12. So it's basically month, day followed by year. So Tableau can infer the right date format and convert it into a date field. So those were a couple of examples where semantics can be inferred using the context of the data to make the right type of default. And these are some other research ideas and projects that have been worked on at Tableau, where we're looking at semantics to better assign sorting or colors to data like Likert scale data. So if you've taken surveys, you probably have seen a ranking where you need to rank something from strongly disagree to strongly agree. And that's a Likert scale in surveys. And you typically don't want to order those in alphabetical order, even though they are text strings. They do follow a logical ordinal order dictated by how they realize themselves in surveys. And in addition to smarter sorting based on the semantics, you could probably also assign more meaningful colors based on the sentiment expressed in Likert data, for example, where red could be mapped to strongly disagree and blue to strongly agree. And you might say, well, I don't quite agree with this mapping because in some cultures, red is considered positive, while in many cultures, red is considered negative. Yes, we could look at locale. We could look at where the user is from or where the data is from to make better defaults. But the point I'm trying to make here is by having some notion of the underlying meaning of the data, the system can make these intelligent defaults. So when you're in the flow of analyzing your data, you don't really have to think about that if the default is right. And you probably would expect the system to learn any behavior if you decide to correct or override these defaults. So similarly, with data transformations, you might have a column called full name. And if you were to split this by space, you want to separate the first name and last name, the default column headers that Tableau would return is something like split column 1 and split column 2, right? And then if you want to manually override that, you'd have to change it. So one of the projects that we've been looking at Tableau is, could we augment the existing data with some additional metadata so that the system can identify what this column might be. So it's not just a column of strings, it could be a column of names. So in this case, the system inferred that this is a name column from US Census information so that we could have smarter transformations. So if you decide to split the column, the default headers would be first name and last name. And you could argue that, this is a really small thing. What's the big deal? But if you think about it, if you're using Tableau every day and you're going through workflow after workflow with multitude of data sources, even these small defaults go a long way because you can just stay in your flow and they're delightful if they're done well. So looking at semantics more from a holistic standpoint and seeing how they can be applied to different parts of the analytical pipeline is something that we're looking at. Another example is about joins. Traditional join processing basically relies on string equality between tables. But with the growing demand for ad hoc analysis, you can see an increasing number of scenarios where the relationship between couple tables may not necessarily be an equijoin. For example, a user might want to join these two tables. One has the country code and the other has the actual name of the country. It would be nice if the system could figure out that these two are semantically equivalent and do the join. Another example is I might have one table with a stock ticker symbol or an abbreviation and an organization name and doing the same thing. And if you take this further, I might have two tables, one in US dollars and the other in euros, and depending on the locale of your workbook, during a join, the system could convert one currency to the other based on the conversion rate of the data. So these are some places where we can really take some of these basic operations further by understanding what the meaning might be. So how many of you saw the keynote? So you saw the new release of Ask Data, where we can support natural language mechanisms for asking questions about data. So this is what Ask Data currently does. So if you have some real estate information about housing, you could ask a question, price by neighborhood with at least 3 bedrooms, and the system will infer fields from the data based on the utterance that you've specified and generate a visualization for you. And kind of walking you through some of the pieces of where semantics has been built into Ask Data and some of the stuff that we're looking at beyond that, let's start with this data set of real estate. It has a bunch of attributes from price to number of bedrooms, square footage area, and so forth. And in Ask Data right now, I can ask, show me house prices. And even though prices is not exactly found in the data source, the system can do a fuzzy match between prices and price. So that's something we already support. You could further go along and ask, show me expensive house prices. And because Ask Data has a notion of what are the currency fields in your data source, it can map expensive to an attribute that has a currency connotation to it, which is, in this case, is price, and set it to a range, a high range of price. But then, as humans, we have different ways of expressing the same question. So I could ask, show me house cost. And something that we're looking at, which is not currently in the feature, is being able to take the definition of cost, for example, and in this case, it has price, could also be a synonym, and map it to the attribute price. And right now, if you want to do this in Ask Data, you would have to manually add a synonym to price, such as cost, and you can ask the same question. But we're also looking at ways in which we can automate some of this, in addition to people explicitly adding these synonyms. And it gets a little bit more interesting if I ask a question, show me large houses. What does large mean? What does it allude to? And if you look at the various attributes and synonyms and definitions of large, it doesn't exactly say area. But then if you look at what area has, it has some common words that are also present in large. So the system could perhaps make an inference that large is related to area and has to come up with some reasonable range, high range alluding to area. But then, like all humans, like my kids are, they particularly get a kick out of stumping Alexa or Google Home. So as you're playing with natural language systems, including Ask Data, you can find yourself coming to an example like this, where I can ask, show me square footage of houses, but I abbreviate it, which is quite reasonable. And there isn't any entry for SQFT, so what do? So something that we've been looking at in research, which is a little bit more complicated, is looking at the notion of word similarity algorithms by computing semantic similarity between different words in kind of this word vector space using large data corpuses, including Google Ngrams, to try to come up with similarities between words that a user might express in their utterance with the underlying data. And that's still work in progress. Trying to come up with a generalizable algorithm to do this for any sort of utterance is still research. So we're still exploring this. In addition to asking questions of the data itself, people might ask questions like this, alluding to the properties in the visualization. So what's the spike in that blue line? So spike needs to be semantically connected to the line chart, looking at the extrema present in the line, and blue has to map to the color in the line chart so that the right line can highlight. And the way we're thinking about this is having some sort of a lexicon dictionary to associate words like spike with lines, in addition to computing a color distance with the color values present in the charts to the actual names. And some of that work stems from the algorithms that I showed you early on around generating these color palettes. So we can compute some sort of semantic similarity between these words so that we can do a couple of things where we not only highlight the line chart that is in play or the line that is in play, but also show a tooltip with a value explaining what that spike is. So finally, in addition to inferring meaning from the data, there's also ways in which data can be enriched from external knowledge, whether it's Freebase or Wolfram Alpha, Wikipedia, Google, or even domain-specific databases that you might be using in your workflows. So those sorts of external knowledge can help with questions like this. What is the drop in July 2016 when I'm looking at pound to dollar exchange rates? So then the system can perhaps go out to the web, put that information out, try to come up with some pithy summary as to what that drop might be, and return an annotation indicating it was Brexit. So now that I've hopefully motivated you on the importance of semantics and visual analysis, Ryan will now talk about the mechanics of realizing semantics in Tableau.
Thank you. Awesome. All right, so we're going to switch gears a little bit and talk about how we represent semantic metadata in Tableau, how it's encoded, and the ways that it impacts the enterprise. And one of the specific pieces that we'll talk a little bit about is how we can start to infer semantic information about your data sources so that you don't have to go in and manually define it every single time. But let's start with some introductory information about how we encode semantics in Tableau today. When you're working with a tabular data source like this one, your data is structured as rows and columns. And if you look at a column, specifically with state data, for example, and you look at an individual value like Massachusetts, there is a bunch of different pieces of information that we already know about that. We know that Massachusetts as a state is inside the United States. We have synonyms, which are alternative names that you might use to describe that state, coordinates, and a polygon that helps us understand how to draw that on a map. These are all different examples of value-level semantics, semantics that help us understand a row or a specific entity in the real world. If you look at the fields, we have a bunch of metadata there as well. We know what the field's name is. We know whether or not it can be aggregated using the measure or dimension classification. We also have information like what the value should be formatted as when shown in the view. This, for example, is how we determine whether or not a field is a currency or a percentage or something of that sort. These are all different field-level semantics. And so we combine these different types of semantic metadata so that we can understand, well, what does it mean that on one particular day it was one particular temperature in one particular state? And how should we treat that information in analytics? So Tableau uses this in various ways. You can take an average of a measure, but you can't take an average of a dimension. We use these semantic properties to help pick the best visualization type in Show Me. So if you've got several different measures, we're going to pick a scatter plot for you. And postal code, for example, despite the fact that being a numerical field, doesn't really make sense to be used in numerical computation, so instead we partition the data and display it either in a bar visualization or as a map. If you have formatting information supplied, we can present those values in nice tooltips with correct formatting. And if you've got map data provided, then we're able to show how your data is displayed in a map without you actually needing to supply coordinates or polygons yourself. Tableau has that built in. So these are all different examples of ways that semantic metadata is leveraged inside of Tableau. And one of the mechanisms by which we do that is through what we call a data role. And so this has been in Tableau for actually some time, as labeled as geographic role. But as of a couple months ago, we've started to expand the breadth of these roles to encompass classifications that are not geography specific. In this case, we just have email and URL as the only two examples. And what these data roles allow us to do is apply semantic properties automatically to your data so that we can take advantage of the knowledge that Tableau has about these things. An example of this working in the real world is with data cleanup, for example. If you classify a field as a country field, then we're going to be able to detect which of the values in that field are invalid. Germany 25 happens to not be a country, but if you get rid of the 25, it is a valid country, and that will allow us to display it properly in the map or join it to other data sources and that sort of thing. Another example comes into play with Ask Data. If I have a data set that shows sales information partitioned by country, and I provide that data set to somebody else and they want to ask about sales in America, with this data set, they're going to run into a problem because there's no data about America. This data set has data about US. And if they were to just filter country in America, they're going to get no results back. But what Tableau does in the Ask Data feature is it recognizes that US is a known country in the world. And so if you just ask a question about America, it'll automatically map that back to whatever's in your data that reflects the country that you're actually trying to refer to. Another example of this, of a similar type of thing happening, involves user-defined synonyms. If you happen to be working with data that doesn't match one of the well-known data roles that Tableau has, you can provide your own synonyms and you'll get a similar mapping experience, where here I have a field called quantity, but if I add a synonym called order size, I can ask questions about either one and I'll get the same results back. And you can kind of imagine how this would grow and scale and how we would add more support for other types of semantic understanding. So things that we haven't done yet, but we are excited about doing in the future, is encoding in fields their unit of measurement. So that if you have a field like flight distance that is in miles, but you ask a question in Ask Data and you use the units kilometers, ideally Tableau would be able to automatically convert your question into the appropriate units so that the visualization result you get back is exactly what you want. Another example would be calculation inference. If you have a data set that has a bunch of birth dates in it for customers or people, and you ask a question about, show me impressions for customers who are over 30 years old. There's no age field in your data source, but if we know that your data has birth dates, we can compute age as a function of the data that you already have. So this would allow us to infer new calculations that aren't present in your data source, saving you the need to write them out all by hand. So these are a couple examples of ways that we could extend the semantics that we have built in. But one of the limitations that exists with the current system, and as of right now, is that this list is pretty limited. You've got a lot of data that doesn't fall into any of these different categories. And so that's why Tableau is introducing this notion of a user-defined or a custom data role. And what a custom data role is, it's a way for you to define your own semantic classification of data that comes built in with it semantic properties that you can leverage to achieve the same level of intelligence and automation that you would get with a built-in data role. So an example that motivates some of this work is take Starbucks. Starbucks has many different beverages. They have many different names for these beverages, and it's very difficult to keep track of them all. You might have different people who refer to the same item using different terminology. So like this drink, for example, is called Nitro Lemon Fog, but if you go to their website, it's referred to inconsistently also by Nitro Peach Tea. And you can imagine this causing confusion and problems if you have different people looking at the same data set and they're not really sure what it is that they're looking at. These are two different data sets that have nutritional information about Starbucks beverages. And one happens to have a field called drink. The other one has a field called beverage. They're both referring to the same thing, the name of the beverage that Starbucks sells. But even within the field, you've got inconsistencies. Cafe mocha without whipped cream versus just cafe mocha over here. And if, as an organization, we're trying to improve the quality of our data, improve the understandability of our data, these kinds of inconsistencies cause problems. So what user-defined data rules would allow you to do is to create a standardized representation and kind of an agreed-upon definition of what a beverage is. And then you can associate your data source fields with that data role. And then in that data role, you can start to define semantic properties. In this case, synonyms, but you could also do other things like the default format of a measure and that sort of thing. And then anytime you associate a field with that data role, that field can inherit the semantic properties of that role. So you define the semantic properties in one place, and they automatically get inherited anytime you have a new field that's related. And so you can imagine that you might have several different fields across many different data sources, and they're all linked back to the same notion of beverage, and they all inherit the same semantic properties. And then you would get to take advantage of the same functionality that you get with the built-in data role. So in this case, I have a user-defined data role called bean variety, and now Tableau prep is telling me which of my values in this field are invalid. Or if I'm using Ask Data and I ask a question about beverages, but my data source happens to have data about drinks, it'll automatically be able to map those two things to each other without me having to manually go in and define the synonym myself for every single data source. So one of the additional aspects that we're exploring is, well, that's great. We can define these data roles. We can automatically inherit a bunch of semantic properties, but it still might take a lot of time to go through every data source that you have and assign it to the appropriate data role. And also, it might be unclear which data role it should be assigned to. So we've developed algorithms in place to automatically detect which data role should be associated with which field. One of the ways that we do that is by examining either a list of the values that exist for a field or a sample of those values and comparing them with the known values or value patterns that exist for the data roles that you have defined, whether built-in or custom, and use that to determine a probabilistic match on whether or not a data role should be associated with a given field. Once we have this information, then we can provide recommendations, like this tooltip that shows up in prep that says, hey, this field looks like it should be associated with this data role. So once you have that in place, and you've got all of your data sources built in, and you're starting to define your custom data roles, you'll start to develop a business glossary. These are all of the different terms that your business may need to use in order to understand what your data means in the real world. But the problem that might arise is, well, what happens when you have many of these things and some of them start to overlap with each other, or some of them start to have inconsistencies with each other? Like this case where I have a data role called employee, employee role or employee title, and somebody creates a different one that means more or less the same thing. All this causes an inconsistency, a problem, something that should probably be resolved. And one of the ways that you might do that is by saying, well, let's merge them together, let's kill one of them, let's get everybody to agree on what the definition of employee role is. That'll make it a lot easier for us to standardize how this information gets trafficked in and out of Tableau and shared within the organization. And that's great. That works really nicely, maybe in this case, if they're really similar. But it doesn't always work. We can't always get people to agree on what information means and how it's defined. Take this example for instance. Customers could be people, they could also be businesses, and the semantic properties of each understanding of a customer are fundamentally different. If I'm a retail company, my customers are going to be individuals who walk through my door and pay with credit card. Whereas if I'm a shipping company, I do business with individual corporations, and the terminology and the validation rules that I use to refer to these things are going to be fundamentally different. Another example happens to do with geography, and so this is actually something that's built into Tableau today. You might think that everybody agrees on what the world looks like from a political standpoint, but they don't. If you look at these regions up in the corner of the Indian subcontinent, you'll notice that some of the country lines are dotted lines. This is what Google Maps uses to delineate that this is a disputed region. If you change your geographic perspective in Google Maps, for example, to the Indian perspective, you'll notice that those dotted lines went away, and now it says that both of these regions exist inside of the Indian country. But if you change to, say, China, you get a very different result. So if you zoom in really closely on one of those regions, you can notice a very stark difference between the different perspectives of the same geographic region. This kind of conflict or disagreement about semantic meaning fundamentally impacts how we use that semantic data in order to improve analytics in Tableau. And that's why when we have things like country semantic properties, it's important to encapsulate them in the appropriate scope so that when different users are using different data sources or applying different data roles, they're able to take advantage of the semantic scope that is meaningful to them. So the architecture that Tableau is starting to build out is this separation between the data layer, which is where your data sources live, it's where your workbooks live, and a separate semantics layer, which captures these shared, agreed-upon understandings of what your world looks like. And then individual data sources can get mapped to roles that exist in that semantics layer. And so you can imagine how over time these semantics could start to unlock some of the capabilities and experiences that Vidya mentioned at the beginning of this talk, helping users reduce cognitive load and understanding what your data visualizations and representations actually mean, getting more valuable and meaningful experiences out of natural language interactions, as well as improving discoverability and governance of data at the server level. So we're really excited about building out this semantics layer to start to capture some of that rich functionality. And all of this is part of a larger vision to help people see and understand their data in more rich and deep and accessible ways. Thank you. Now we have some time for questions or points of clarification. Yeah.
Tell me more about the semantic layer and how that, where it will live. You know, it's not a TBS, right? It's something new. And then a follow-on question is, what about industry, like common semantic layers, like industry-specific semantic layers that then specific organizations could customize and extend for their unique situation?
Yeah, those are great questions. So the semantic layer lives in Tableau Server. The predominant use case for that semantic layer is to share semantics across users and data sources. It also lives in desktop and prep, but the place where you can define user-specific data roles is in server, and that's where the custom data roles can be managed. And then as far as industry-specific data roles that might be reused across different companies but aren't necessarily global, yeah, that's a great question. Tableau right now, as part of the built-in data roles, are mostly global semantic ideas, things like people or places and businesses. But we're definitely exploring ways that we could have retail or finance or other different industry-specific data roles that maybe aren't globally applicable, but that you could opt into using in your environment or extend yourself to customize to meet your specific needs. Although that's not something that we're doing in the first version of this layer. Yeah, so in 2019-1, you'll be able to define your first custom data roles, and you'll define those inside of prep. And then in future releases of Tableau Server, we'll introduce improved governance capabilities and that sort of thing. Other questions? Yes.
So talking about the use of revised systems, will it be part of your 2019 data fact sheet as well? That we allow you to use the
Yeah, so you can define your own synonyms on data sources in Tableau in 2019.1 as part of the Ask Data feature. And then where this ties into the semantic layer is if you add synonyms to a data role, then you can have fields automatically inherit those synonyms. That won't be in 2019.1, but it'll be something that we'll add in a later release.
Yeah, so right now, Ask Data is focused on US English, but I mean, right now, we want to focus on getting the experience right for one language and then spread our wings to other languages. So it is something in our charter, but not for the interim, probably in a few years, couple years, we'll start building it out to other languages.
Yeah, that specifically is accurate for the Ask Data feature and our ability to understand natural language questions. The semantic layer itself that Tableau has is designed to support multiple languages simultaneously, which is especially true for the geographic data roles. Tableau supports, or it has an understanding of countries and cities and states in, I think, 8 different languages. I could be wrong about that number, but it's
8.
It's somewhere.
There was a new language that was added.
Yeah.
most
So
recently, yeah.
so the data roles that you create do support multiple different languages simultaneously.
Now that, for example, thinking in America, when you say America and US, everybody thinking US, as if you say North America, America, thinking of all the continents.
Okay.
Canada,
Yeah.
you are thinking America sells to a company located in, I don't know, Argentina, thinking of all the sales in all the companies in America. US, Canada, all the companies.
Yeah.
I don't know if right now you put how myself in America, only US, show only the US sales or all the companies.
That's a great question. And so it's because of, so the question was, well, what happens if you have one definition of what America is in the United States, but in larger North and South America, you have a broader definition of what America is. And it's for reasons like that the stance that we have is we don't want to force everybody to agree on what all of these terms necessarily mean, but rather provide sensible defaults with the ability to extend or customize whenever you want. So you can go in and provide your own definition of what America is, and even define your own semantic context where that gets automatically inferred. At least that's the direction that we want to move.
Yeah, I mean, I think cultural appropriation and just regional appropriation is a big aspect of this, right? Even with colors, for instance, people have different interpretations of what colors might mean. Red means something different in China versus, say, here. So, I mean, as Ryan alluded to, I think the fact of the matter is you have defaults, and we also want to build an infrastructure that has different scopes of what these semantic roles could be, right? You could have something that's defined just for you, for the data. Could be something that's persistent just for the data source itself, or it could be something that's tied to locale. So there are different scopes of how semantic interpretation needs to be built out, and we're taking small steps in that direction. While you're thinking of other questions, I just wanted to highlight this. I know this is the last day, and I'm not sure what the availability of Tableau Labs is in terms of their scheduling for today, but there are a couple of activities, if you haven't made your way to the Data Village, that are related to Ask Data and kind of natural language in general. So if you have the time, feel free to stop by labs and take part in any of these 2 activities. A lot of the research, the user research that goes into these activities helps inform future product development. And also with the Ask Data feature, if you want to sign up to test out the feature, you can go to this link or meet us after the talk, and I can actually give you the URL, or you can give me your name, and I'm happy to add you to the program, the beta program.
Yeah, we are always excited about getting in touch with more customers who want to test out the feature early and give us preliminary feedback. We absolutely take into account that feedback and use it to improve the feature. Customers are oftentimes very surprised by the level of influence they have on how the feature grows and improves.
Any other questions?
Yes.
Yes.
We're kind of piggyback off your first question. Is there any plan for, not necessarily just Tableau official things, but more like user community to share?
That's a great question. There's no plan for that per se, but you're definitely not the first person to bring it up. So it's something that we've been talking a little bit about internally. And I think as we kind of roll this out and expand the built-in data roles and our understanding of what kinds of ways people are going to end up using this information, it'll make more sense to make plans about what that community actually looks like and how much sharing is going to happen. Yeah, possibly.
Yeah.
If you got time,
Yeah.
drill down a little bit more on how you were describing the user-defined roles will be defined in prep, you said?
Yeah, so for the first version, you can define custom data roles in prep. And in later versions, you'll be able to define them in other places as well, like in server or in desktop.
Oh, okay. So initially, in 2019-1, you won't be able to publish those user-defined roles out of a prep flow onto server.
You will be able to publish them out of a prep flow onto server in 2019.1.
So then are they mobile to that site?
Yes, that's right. Yeah. Yeah.
So how much behavior is available in a user-defined role? So for example, you were talking about pulling in other external semantic-related data. How much of that can be defined in a user-defined role? Can be too sophisticated out of the gate.
Right, yeah, out of the gate, it's going to be a pretty targeted functionality. Specifically, you can define validation rules of what the patterns might be for a data role, like a regular expression that says this is what an email looks like or a product code looks like. You can also provide a list of known domain values that you can use for data validation in prep. And that's it for the first version. But in subsequent versions, we're looking at adding the ability to add synonyms, related information, hierarchical structures to support some of the same things that we have with the geographic roles.
If there are no other questions, thanks for coming.
Awesome.